Hello, I'm Mike, and welcome to my channel. In previous videos, I have shared various methods to generate a loan amortization plan using Excel traditional functions, VBA code, and array formulas. In today's video, I will introduce a new approach using the LAMBDA function alongside the array functions like scan and let to create a formula for generating a loan amortization plan. Then we will take it a step further by tuning the formula into a customer function called loan amortization plan using LAMBDA. This customer function works just like the Excel built-in functions, allowing us to reuse it effortlessly without needing dynamic array or macros. Alright, let's get started. To create the formula, we start the first section with the let function. This function allows us to define and reuse variables, making complex formulas easily to manage. Here are the main variables. Loan is a loan amount taken from the cell C2. Rate is the annually interest rate in cell C3. Number of the period, nper, represented the number of months or payment periods from the cell C4. Start is the loan start date found in cell C5. These variables makes our formula dynamically, so any changes in the inputs automatically updated the result. Next, it is section 2, calculating payment and generating sequences. We calculate the monthly payment using the PMT function. PMT rate divided by 12 and the number of the period and then minus loan divides the annually rate by 12 for monthly payments, splits the loan across number of periods like the months, and ensure the payment is positively by negating the loan. Now we create the sequences of months using the sequences function. Here I pop up the definitions and the descriptions about sequences regarding the purpose of the function, the syntax of the function, and the required parameters of the function. Sequences nper 111 generates a series from 1 to the number of the periods. The dates variable using the EDATE function to add months to the start date and format them as a day, month, and year. The section 3 is for tracking balance and interest. Now we calculate the balance and the interest. First, the payments variable uses the sequences function to generate a column of the fixed month payment amounts over the total number of a payment period, nper. Each value in these sequences is identical, starting at the payment and maintaining a step of 0 to reflect constant payments. PREVBAL tracks the loan balance before each payment using the scan function. The scan function is a powerful LAMBDA helper function that scans or processes an array by applying a formula cumulatively across its elements. It returns an array of all intermediate results, making it particularly useful for operations where cumulativity calculations are required. We use this function iterates through each month, adjusting the balance. BAL calculates the remaining balance after each payment, ensuring it does not drop below zero using the max function. We also compute interest as a PREV balance times rate divided by 12, showing the monthly interest. Principal as the portion of the payment that reduces the non-balance calculates as payment minus interest. Accumulate interest, which uses the scan to sum up the total interest paid over time. For final step for section 4, building the table. This step is building the table. Headers contains column title like the month, payment date, previous balance, and more. Tables combines all the data into one matrix using H-stack to align the columns. Finally, V-stack adds the headers to the top of the table. The result is completed loan amortization schedule, showing each month's payment, interest, principal, accumulated interest, and remaining balance. Let's review the formula. As you can see, it generates the expected loan amortization plan in an array table layout. Copy this formula as we will use it in the final step to create our customized function. Next, we will list the lead formula into a LAMBDA function with the required loan input variables to create a reusable and general-purpose customer function called loan schedule demo. The LAMBDA function allows us to define customer reusable function directly in a worksheet without needing VBA or external add-ins. It lets us specify a logic with parameters and reuse the logic, making complex calculations cleaner and easier to maintain. Here is how we do it. Write the LAMBDA formula starting by declaring the required variables, loan amount, interest rate, number of peers, and start date. Paste the previous created array formula for generating the loan schedule. Remove loan input variables already declared in the let function. Copy the entire LAMBDA formula. Now go to the ribbon, click on Formulas, and select Name Manager. In the pop-up, create a new function, name it as Schedule Plan Demo. And paste the copied LAMBDA formula into the formula field. Your customized function is now built in and ready for use. To test it, find an empty cell and type the formula equal to schedule plan demo. Fill in the loan input values according to the required variables. When you apply the formula, it generates a completed loan amortization plan. Amazing. You can also test different loan inputs compare the result with those generated by the macro we have created early, and confirm there are no errors. This brings us to the end of our journey in creating a customized loan amortization function. That is all for this video. I hope it helps you enhance your Excel analytic skills. Thank you for watching. Don't forget to subscribe to my channel for more tutorials. I will see you in next video.